Okay, hey information assurance class, this is Clay. I wanted to follow up on an attack that I tried to show you in class last time, but which didn't work. And it was the attack in which we were going to abuse symlinks in order either to get a program to read from a configuration file which we created, or to get a program to overwrite the secret text file with with the contents of the log file so we would know what it was in either way. So what I'm going to do now in this is kind of casually and informally, and hopefully you'll be able to see this on the screen, I'm going to walk you through some of these attacks. And I'm trying to make the typeface bigger. All right, so here's what we're going to do. And I'll just make some notes right here. The first thing we're going to do is we're going to create a configuration file. Configuration file that has stuff that we know. The second thing we're going to do is we are going to create an attack directory that has our configuration file and links to the program and other files. And then we're going to run the attack. Okay. Now, it's all going to be hopefully pretty straightforward, and hopefully you'll be able to follow along. I'll try to explain what I'm doing as I do it, and if you need to, hopefully you can go back in the video and take a look and see. So, first step, create a configuration file. So I'm going to go back from my home directory. I'll just show you where I am. Here I am, I'm starting on my home directory, home clay. I'm going to cd ... and do an ls, and that shows me all the other directories. Now I happen to know that the user that I want to attack is user 6EAD49, so we'll go in their directory and take a look at what's there. So if we take a look at their configuration file, we can see that it looks like, clay and some long hash. Or user1 long hash, Azure diamond some long hash. So let's take a quick look inside their C file and see what they're doing. Well, here right at the top we can say SHA-256. So it's pretty clear that they're using SHA-256 as their hash algorithm. Now what ends up being different between programs is exactly how the password is treated when it's passed to the hash function. Some programs strip the end of line, some do other things. The easiest way we're going to get this to work so that we have a known hash is we're going to copy their program and edit it so that we can just use it to create hashes. So here's what I'm going to do. I'm going to go to the /temp directory, which, as you remember from your first assignment, is a directory that anybody can put temporary things. And I'm going to make a directory that is user 6EAD49. And if I take a look at all the directories here, you can see there's now this user 6EAD49 that is owned by Clay. So it's my directory even though it's user 6EAD. So let's go into user 6EAD. Oops, sorry. User 6EAD49. And now what we're going to do is we're going to copy tilde user 6EAD49, user 6EAD dot. And what I just did is I copied the program file, cc, to this directory. And if we look, there's our cc directory. Now I'm going to go ahead and just quickly edit this. And what I'm trying to do is just do the minimum amount possible so that I can use the code in there to generate hashes. So if we look at their code, here's a line that asks for username. We're not going to need that. And so what I'm going to do is we don't need the username. We need the password, and then down here it checks if the password is correct. And the way it does that right here is you can see it says it creates a SHA-256 a password. So what we're going to do is we're going to take that code. Sorry, keyboard error here. What I'm going to do is I'm just going to go ahead and cout --, SHA-256 password ENDL. And then that's all I need. I can now return 0. And I can close the program. And I can just delete all the other code underneath here that doesn't relate to generating the hash. Okay? So now I have changed this to I have changed their program to do nothing but generate passwords the way that their program does it. So let's compile it, make sure that this went well. Remember, I need the crypto library, and I'm going to put it out as pass.exe, which is a password generator. So it compiled without error. Now let's run pass.exe and see what happens. Oops, sorry, /pass.exe. So we enter a password, we do something like swordfish, and we get B9F195. And now we can check, and we can make sure that that matches what we had in there. And we can see B9F195, which was Clay's password. So it looks like we're creating passwords correctly. So now what I'm going to do is I'm going to create another password, and we're going to call it hacker. Whoops. Hacker. And we get E7D. I'm going to run that one more time just because I wasn't sure I ran it correctly. We'll make sure that I typed it the same both ways. So we get, okay, E7D368. And I'm going to copy this. This is the hash. And now I'm going to use my editor to create my own configuration file. And the configuration file I just created has the name hacker as a username, and then hacker hashed as the password. Okay? And what we're trying to do is fool this program, user 6EAD49, into using our configuration file. So I save it and I exit. Okay, so here I am. I now have this configuration file, and I can run the program by doing this, // home user 6EAD user 6.exe. Okay, and when I run it, I can say hacker. Nothing seemed to happen. So I'm not able to tell very easily if it worked or not. So let's do something else. Let's use the strace program, which shows you the system calls that the program that's being run is doing, to get a look at what's going on inside the program. So I can see it makes a bunch of different calls, mmot, protect, break, fstat, and finally gets down to read. And what it's reading here is, it said please enter username right here. So it's looking for my username, so I say hacker. Please enter the password, I say hacker. And now we can see that it opens the configuration file, and it reads from the configuration file hacker and the password. And look, it goes, hey, password successful. So that's awesome. The program ran, it read our configuration file, it matched the name and the hash, and it says successful. So we're trying to, do we want to add a user? We say no. And now what happens? Well, it goes to read the text file, and it says no such file or directory. Okay, so it couldn't find the file directory, or the text file wasn't there. So let's see what's going on. If we do an ls, there's the cc file, the config file, and the user log that was just created. We just created log, but there's no text file. No problem. What we need to do is we need to do ln-s ... home user 6EAD user 6EAD.txt dot. And now if I do a listing, you can see that this program this file user 6EAD49.txt exists. But what it is, because of this arrow, it's a link, and it points at the actual program, at the actual secret file. Okay? So now when it runs, it will try and get the actual secret file. So let's go ahead and run it again in strace. It reads hacker. It reads hacker for password. And now it matches again because it read our configuration file. It says, would you like to add a user? We say no. And user.text permission is denied. So this is what I showed you in class, and this is where things went wrong, and I thought the operating system was still doing the thing where it protected the file. That was a mistake on my part. And what actually happened was my file permissions were incorrect. So let me show you here. So these file permissions, the configuration is owned by Clay, the text file is owned by Clay. It turns out that in order for this attack to work, all of these files, the config file, log file, and text file, have to be readable by everybody in the world, and the directory also has to be readable. Because what's actually happening is when the SUID program runs, it runs with the permissions of user 6EAD49, And because all these files are in a home directory, my home directory, for which it doesn't have permissions, it doesn't work. So what I'm going to do is I'm going to chmod all plus read, write, and execute as necessary dot, which is the directory, and user star. And now it said couldn't change permissions of user's text, which is fine because that was actually file owned by user EID, not me. But if I do an LL, we can see now the directory, which used to be only partially readable up here, right, only by the owner, is now readable by everyone. The config file is readable and writable by everyone. The log file is readable and writable by everyone. Everything's set. So now let's try it one more time and see what happens. We try hacker. It reads the password file. It's successful. We're going to add a user. No. And hey, look at this. It worked. Now we see after elect a user, it writes secrets of content file. Oh, wait a minute. Sorry, I was incorrect. It didn't work. In this case, it didn't work again because permission was denied. Okay. Well, the problem with this is actually that I think because we're running it through strace. And if we do it this way, hacker and hacker, password successful, would you like to add a user? No. And there you go. Contents of the secret file. You have opened the secret file. So what we just did there, and I probably went a little bit fast, but we got the user's program, extracted their code by which they create passwords through their hash, wrote our own, wrote our own version to create passwords of the same format they used those passwords to create our own password file, and then using the SIM links and everything, we got it to read our own configuration file and output it. Now along the way we saw a couple of bumps. One bump was that in order for this attack to work, all the directory permissions had to be readable. The other bump is that when you actually run it through strace, strace cannot run an SUID program as SUID. When you run something in strace, it essentially takes the SUID bit off because strace allows you to manipulate the internals of the program, and that would be bad for an SUID. But we did manage to change the contents of the secret file. So let me just see where we were. So did we create a configuration file? Yes. Did we create the attack directory? Yes. And this was world readable permissions, which is what went wrong for me in class the other day. And do we run the attack? Yes, but not through strace. Okay, because if you do it through strace, it doesn't work. Now let me just quickly show you the one other thing that we can do. And this is kind of fun. If we want, we can take a look at the log file and we can say, oh look, this log file has hacker trying to get into it. What we're going to do is we're going to remove this log file and we are going to create a symlink to the log file. But for the log file, what we're going to do is we're going to make a symlink that goes to the secret text file, but we're going to call it the log file. So what the program is going to end up doing when it runs and it's time to log something is, if we do this list now, you can see the log file exists, but it is essentially a pointer to the text file. So when the program runs, it's going to try and log that hacker logged in. And where is it going to put that? It's going to put it in the end of the text file. It's going to kind of help overwrite the text file with that. So let's try it and see. So here's what I'll do. I'm just going to run the program. Any name will work. I'm going to call it Frank because we don't even have to worry about getting into the program. And now we type some random password and we didn't get in. When I type ls, now if I cat the log file, I don't have permission. And I don't have permission because this log file actually points to the user's secret text file. So let me show you that log entry was actually added to the end of the user text file. And the way we're going to do that is we're going to go into that user's account, and at least directory, and we are going to run their normal program the way it works with a password that we know, clay and swordfish. and we'll look and see. We'll say no. Ah, come on. Okay, so the reason, I just took a minute to look into it, and the reason that that attack didn't work was, it's kind of a funny one that I didn't even think to look at before I started the video, but let's go take a look and see what it is. So if we cd to the user's directory, and we do a list, we can see that their text file is not writable. So the permission error comes not because the attack doesn't work, but because the text file is not writable, and I feel dumb about that. So this attack would probably work against other people who left their text file readable by so let's see if there is anybody like that. We'll find dot dash name star dot text dash exec ls dash l, and we'll see if we can find anybody who looks kind of like that. All right, so it looks like in the instructions to the thing, I actually told you to make your text file. Oh, here, this one's writable. So user 4BD-E19 might be vulnerable to that. Let's see, 4BD-E19. Their text file is writable. So you could probably use the attack that I just showed you to overwrite their text file with a log file. I'm not going to do it now. Hopefully you get the idea. Okay. I hope this has been helpful. I'm sorry it took so long to get to. I just made a dumb mistake in class and didn't have the answer. So I did want to take the time and follow up. Based on this, you should be able to attack programs whose configuration file is just the name of the configuration file and doesn't have the full path to the actual file. So I'm going to go ahead, I'm going to put this up. Hopefully this will help and you'll be able to run this attack by Tuesday. Thanks, bye.